Okay, hi everyone. So today you're welcome to Best Science Brain YouTube. So today we are looking at Alternative A, Physics 2023 Practicals. In the previous video I made, I said that the first question you're going to see in this year's physics examination, practical examination, will be on two different areas, The first one is on helical spring. That is same harmonic motion on helical spring. We have done the video of that one. And the second one will be on principles of moment. So today we're looking at experiment on moment, principles of moment. We have done that on helical spring. You want to find out, go through our YouTube channel and then search for the experiment on helical spring at Best Science Brain YouTube channel. You're going to see that. Today we're going to look at moment, but bear in mind that the experiment could either come from helical spring or from principles of moment. Two of them cannot come together, but they provided the apparatus for both helical spring and for that of principle of moment, just to create a kind of a contradiction. But one of them will surely come out. So indeed, on the whiteboard we see a knife edge suspended at the 60 cm mark of the meter rule. We also have two masses, Q and mass P, given to you. The mass P is 100 grams, while the mass Q is 20 grams. Then we ask that value G. The G represents the center of gravity. That is the place or the point where the meter rule will balance when there is no mass hung on it. So the center of gravity for the meter rule we're going to use are determined as 50.00 centimeter. So we have obtained our center of gravity already for the meter rule. That's the point where the meter rule balances when there is no mass hanging on it. So from this experiment, what are the parameters required here? We are going to the point here where the Q is hanging. They call this point LCM. So the first point where our Q is suspended is 10 cm. So we're going to suspend Q, the mass of 20 grams, on the 10 cm mark of the meter rule. Then we suspend the mass of 100 grams on the other end of the meter rule, and then we are going to adjust this mass of 100 grams on the meter rule balances horizontally. So we still need to find our A, or the value is here is 10 cm from here. Okay, S, this is our S. Our A will be the distance from here to this point. So for this, when the mass is hanging on the 10 cm mark on meter rule, the value of A will now become 60 minus 10. That will give us 50 cm, 50.00, 10.00. So having done that, we want to get our Y from the experiment and also get our B. So Y will be the balance point of the 100 gram mass. We also get our B. So repeat myself. We have the setup on the whiteboard. The center of gravity is determined as G. That is the point where the meter rule balances without any mass hanging on it, which are determined before the experiment as 50.00 cm. Then we're going to hang the mass Q at the 10 cm mark of the meter rule. When we hang it, we now put the mass of 100 grams on the opposite side of the pivot and adjust the 100 gram mass until the meter rule balances horizontally. Now, we are having S for the first experiment is 10 cm. Then the value of A from here to there should now be 60 minus 10. That will give us 50.00. So we'll go to the experiment and then find our Y and then our B. Okay. So as you can see, see that the mass, the Q is suspended on the 10 cm mark, while the balance point where P is at 80.6 cm. So Q is at 10 cm mark, show it. Q is at 10 cm mark, and then our P, the 100 gram mass, is at 80.6 cm. And if you look at it, you see that the masses are not touching the table. These are a set of static equilibrium. So that means the value here where Q is 80.6, then that value corresponds to our Y. So 80.6, we now write here 80. Then how do we find our B? To find B is going to be 80.6 minus 60. Okay, do it. 80.6 minus 60, and that will give us 20.60. Okay, then for the second experiment, we're going to keep this mass now. Instead of our 10 cm, we'll bring the mass Q to the 15 cm mark. So we bring the mass Q to the 15 cm mark. The distance between Q, the mass Q, and this point, the point of pivot, that is, will now be 60 minus 15. So here won't be 15 now. Will now be 60 minus 15. That gives us 45.00. So we'll go to the experiment and then find our Y, the point of balance, and then find our B. So as you can see, the mass Q is now resting on the 15 cm mark, and then the balance point for the mass P is at 79.50 cm. And this is instead of equilibrium. None of the masses is touching the table. So we now have here 79.50. This is the point. Then to get our B will be 79.50 minus 60. That gives us 19.50. The third, we're going to put our S at the 20 cm mark. So here will now be 20. We'll put our Q, at the 20 cm mark. Adjust it to 20 cm mark, and then we adjust the 100 gram, which is P, until it balances. Before we go on to the experiment, what will be the value of our A now? Our A will will now be 60 minus 20. That will give us 40.00. So let's go back to the experiment and do the adjustment on this mass and then get the meter will balance. So as you can see, the mass Q, the 20 gram mass, is resting on the 20 cm mark, and then the 100 gram, which is P, is now at the 78. This is 78.2 cm. And this is the state of equilibrium because the mass is none is touching the table. So that is 78.20. To get our B, this value will now be 78.2 minus 60, and that will give us 18.20. The next, we now put the mass Q, which is the 20 gram mass, on the 25 cm mark. When we do that, before we go to the experiment, we find out A first. The value A from here to here, we're going to be, if here is at 25, we now have 60 minus 25. That's going to give us 35.00. So we're going to go to the experiment and adjust this mass until we have a balance point. So as you can see, the mass now Q, that 20 gram mass, is lying on the 25 cm mark. Then the balance point, which is now 77.7 cm. And mind you, in all the experiments, make sure the fulcrum is at 60. This place is constant at 60 cm. So what happens 0? And that represents the value of Y. Now to get our B is going to be 77.70 minus 60. That gives us 17.70. We go to the fifth. The fifth one, we're going to keep S at the 30 cm mark. So S being at 30 cm mark here. If S is at 30, so if Q is at 30, sorry, S is the point, 30, then Q being at 30, the distance A will now become 60 minus 30, that is to give you 30.00. Having done that, we can now adjust 100 gram mass on the other side of the pivot and to get a balance point of Y. So as you can see, the mass Q, which is the 20 gram mass, is resting at the 30 cm mark for the meter rule, while the 100 gram mass is at 76.50. The fulcrum is still maintained at the 60 cm mark. And when you look at the diagram, this is static equilibrium because the objects are not touching the desk. So we have 76.50 is the position of our Y here. So we have 76.50 at this point. Now to get our B, that is this distance, will be 76.5 minus 60, and that will give us 16.50. So the next is we're going to keep the Q at the 35 cm mark. So if here is 35, the distance from this point to here will now be 60 minus 35, that is 25, our A becomes 25.00. So go to the experiment and get our balance point by adjusting the 100 gram, which is P, the 100 gram mass, until the meter rule balances to get our Y. So as you can see in this one, the Q, the 20 gram mass is resting at the 35 cm mark. The pivot is maintained at 60, and then the 100 gram mass is at 75.6, and you see we have a state of equilibrium here. So we have with the value of Y in this case now. Then to get our B goes to be 75.6 minus 60. So 75.6 minus 60 will give us 15.60. Then one more. Now, if our S is now 40.00, that is, if we keep the Q at 40.0, that is 40 cm mark of the meter rule, our A will be 60 minus 4, that gives us 20.00. Then we're going to adjust the 100 gram mass until have a balance point here. So let's go back to the experiment and keep our Q at the 40 cm mark. Okay, the mass Q, the 20 gram mass, is at the 40 cm mark. Then the balance point here is 75.6 above 0.5, 75.6, 74.6 here. And then the 9A is still maintained at the 60 cm mark, and we have a balance point here. So the value of our Y, 0.60. Then to get our B, is 4.6 minus 60, that will give us 14.60. So, as we said before, initially, this is alternative A, 2023 physics practical Waec examination, specimen being displayed. The first experiment we did was on helical spring. In the first question, you either see a question on simple harmonic motion involving the helical spring. We have done the video before. Or you can see question coming from the principles of moment. We have two masses, one labeled P, one labeled Q. The Q is the smaller mass, which is 20 gram mass, while P is the bigger mass, which is 100 gram mass. The first thing we did here was to suspend the meter rule on the 9A to get the balance point. That is G. G is the center of gravity. Then after, the meter rule was shifted to the 60 cm mark and kept at 60 all through the experiment. So we hung the 20 gram mass, which is Q, on the 10 cm mark and adjusted the 100 gram mass on the balance at 80.60. We evaluated A. A is the value we're gonna have 50. Then to get B will be the value here minus 60. In this case, 80.6 minus 60 will get 20.6 and so on. Having done that, we create another column. This column here, we're going to have A inverse. Calculator please. A inverse. We're going to create another column for B inverse. So can you get A inverse for me? A inverse 1 over 50. 1 over 50 will give us 0.0200. 1 over 45 please. 0.02. 22 continuous. 1 over 20. 0.050. 1 over 25. 0.040. 1 over 30. 0.033 continuous. 1 over 35. 0.0285. 1 over 40. 0.250. Then find the inverse of B for us. 1 over 20.6. So please let's go to the inverse that it is somewhere. 1 over 50 is 1 over 45. Let's confirm the values.
0.0222.
1 over 40. 1 over 40.
0.050.
Are you sure what they're saying?
0.025.
0.0250. Do 1 over 25. 1 over 35. Well, I have an error. I have to correct it.
0.0285.
0. What?
0285.
Well, the values were somehow varying wrongly. 1 over 30, 0.33. 1 over 25, 0.04. That's right now. 1 over, what again? Is it 20? What about 20 is what?
0.05.
So it's right, because if you look at the values are increasing. Then let's go to B. Find 1 over 20.6. 0.0485. Then find 1 over 19.5. 0.0512. Find 1 over 18.2. 0.0549. Find 1 over 17.7.
0.0564.
0.0564. Find 0.0564. Find 1 over 16.5. 0.0606. Then find 1 over 15.6. 641. Find 1 over 14.6. 684. So make it to 4 second figures. 4 SF. 1, 2, another 0 here. 1, 2, 3, another 0 at the back. To make all of them uniform to 4 second figures. So we have our table here for the value we have done on this particular moment. So you could be expected to plot a graph of A against B, or you have to plot a graph of A against B inverse, or you have to plot a graph of B against A inverse. So you can get the relationship here, and you have a graph of the relationship you calculate using a graph. In physics, we interpret data using graph. Okay, so let's go to the graph. Okay, as you can see on the board, you see the experiment again being reviewed, the data on the board, the serial number on the first column, second is S, where S is the position where Q or the 20 gram mass was hung. Then the next column shows A. A is the difference between the 60 cm and that 60 cm is where the pivot is, and S. Then the next column will have what? Y. Y is the position where the 100 gram, which is B, balances the 20 gram mass. Okay? The next column is A inverse, and they will have B inverse. Then going to the table, the values, go to the table please. We'll have the values on the table. We'll show the table. I have 10 on the first column, 10 for S, then 50 for A, 80.60, 20.60 for B, 0.02 for A inverse, 0.04850 for B inverse. Second column, the value of S is 15, that's 15 cm, A is 45, then Y is 79.50, B 19.50, A inverse 0.022, and then B inverse 0.05120. Then the third column will have S as 20 cm. S, remember that S is where the 20 gram mass is hanging. You can show the diagram up. See the position of S. S is where the 20 gram mass is hanging. G, the center of gravity, and then the pivot is at the 60 cm mark. So go back to the third experiment. So S is 20, A is 40. How is A obtained? A is obtained by subtracting 60 minus S. That is the value of A. Y is where the 100 gram balance horizontally. Then Y is 8.2. B is 18.20. How do we get B? B is the point Y minus 60. That is B. Then A inverse is 0.025 and B inverse is 0.05490. Then when S is 25, that is when the 20 gram mass, which is Q, is hanging at 25 cm mark. Our A will become 35, that is 60 minus 25, giving us 35. Our Y, the balance point for the 100 gram, is 7.70. Our B is 17.70. A inverse is 0.02850. B inverse is 0.05640. Then when S is 30, that is when Q is hanging on 30, we got A as 30. That is A is 60 minus S. 60 minus 30 is 30. Remember that 60 is where the pivot is. Then our Y, that is where the 100 gram balance the meter is at 76.50. Our small letter B, which is the value of Y minus 60, that is 76.50 minus 60, giving us 16.50. Our A inverse, that is 1 over A, 0.0333. Our B inverse is 0.06060. Then when our S is 35.00, we now have, that is when the 20 gram mass is hanging out. That is the Q is 20 gram hanging out as 35 cm mark. Our A is 25. A is 60 minus 35. 25. Then our Y, where the 100 gram balance the meter rule, is 25.60. Then our B, which will be Y minus 60, 75.60 minus 60 gives us 15.60. Our A inverse, which is 1 over 25, is 0.0400. Our B inverse is, which is 1 over 15.60, gives us 0.06410. Then for when S is 40 cm, that is when the Q is hanging at 40 cm mark. We have our A, difference between 60 and 40 is 20.00. Our Y, where B balance the meter, B is the 100 gram mass, is 24.60. Our B, with the difference between 4.60 and 60, is 14.60. Our A inverse, which is 1/20, is 0.0500. Our B inverse will have 0.06840. Please go back to the slide. Film the diagram again. So look at the diagram again once more. Q is something at S, while the pivot is maintained at 60 all through the experiment. Y represents the point where the 100 gram will balance the meter rule. A is 60 minus S, value of S. So if S is 10, A will now become 60 minus 10, that will give us 50. If S is 15, A will now become 60 minus 50, that will give us 45, and so on. Our B value is the difference between Y and 60 in each case or in this experiment. So we're going to plot a graph of A 50, 45, 40, 35, 30, A against B inverse. So we'll go to the graph book. So as we can see, this is the reading we have on the table, on the board, and this is the experiment we have. So the diagram, this is the first point of suspension for S, 10 cm. This is the pivot at 60, and then Y is the balance where we have the 100 gram where it's hung to balance the meter horizontally as we did the experiment. So we have obtained our data. The data is here already. We're already giving it out on the board. So we are plotting the value of A, 50, 45, 40, 35, 30, 25, 20. We cannot take the whole 7 values. We can just pick 5 out of these 7. So for convenience, I pick from 50 to 1, 2, 3, 4, 5, from 30 to 50. So you can see it here. The scale A on the vertical axis will maintain 10 cm to 10 unit to 2 cm, or 10 unit to a bus, 10, 20, 30, 40, 50. So we have to expand the reading, add more values for intercept. Then we'll now look at this. The B inverse values 0.04850 corresponding to A being 50, 0.05120 corresponding to A being 45, 0.05490 corresponding to A being 40, 0.05640 which correspond to A being 35, 0.0606 which correspond to A being 30, and so on. So we're taking 5 values for B inverse, which is what we have here scaled. On the B inverse axis, we have 1 bus or 2 cm presents 0.02 units. This is 0.02, 0.04, 0.06, 0.08. Okay, having done that, as we used to do before we plot our graph, we have to find out what does one tiny line represent. So for the A axis, to find out what one line represents, we divide 10, the first unit here, divide 10 by 10 lines. So we have 10 divided by 10 lines, that will give us 1 unit. So one line on the A axis is 1 unit. Then on the B inverse axis, what does one line represent? Divide 0.02 by 10 lines. 0.02 by 10 gives you 0.002. So one line here is 0.002. So we can count our reading. So when we plotted the first 5 readings on A and the first 5 on the B inverse, we got an inverse graph. We took our slope. When we took our slope, we obtained 36 over this. We obtained a slope as 1028.6 cm squared. Up here is cm, while under divided by what cm, that gives you cm times under cm over 1, inverting this. Cm times 10 gives you cm squared. Then we have to evaluate k. To evaluate k as s over 20, where s is the slope, 1028 over 20. We divide it, we have 51.4. 51.4 is a close range to the center of gravity, which is recorded as 50.00, showing that the experiment is within the limit of accuracy. To obtain the center of gravity at 50.0, and then from this calculation we're obtaining 51.40. So the 1.40 error should be experimental error. That means we're in line with this, we are correct. If you ask to find the intercept on the particle axis, the intercept on the particle axis is 100. And of course, half of 100 will give you 50 with the center of gravity. And you have to find the intercept on the horizontal axis. So the intercept on the vertical axis, let me call it C1. For this is 100 cm. The intercept on the horizontal axis, let me call it C2. The intercept on the horizontal axis, let's call it C2, become, if really, since remember that one line here is 0.02, this is 0.08, 0.082, 84, 86, and 88 will give us 0.088 per cm, being the intercept on the horizontal axis. So with this, we have come to the end of this experiment. Some may ask us precautions. What precautions did you observe while doing the experiment? That is a common question that nobody asks in examination. Precautions. You will say, I ensured that I avoided error due to parallels in reading the meter rule. That is one precaution. The other one, you can say, I ensured or I made sure that I avoided air interference in balancing the meter rule. We know that one of the problems we have in this experiment is that air will disturb the equilibrium. So how do you avoid air interference? You close the windows so that you don't have the meter rule will not be dangling. Then these are some of the precautions you have here. Someone can ask you, state the principle of moment. The principle of moment states that for a body to be at equilibrium under the action of a system of forces, the total clockwise moment must equal the total anti-clockwise moment. For a body to be at equilibrium, the total clockwise moment must equal to the total anti-clockwise moment. So may ask you to find a couple. A couple is a pair of two equal but opposite forces. That is what called a couple. So may ask you to state the conditions required by a body to be at equilibrium under the action of parallel coplanar forces. Because the first condition is the principle of moment, which states that total clockwise moment must be equal to total anti-clockwise moment. Second condition is that total upward forces must be equal to total downward forces. Total upward forces must be equal to total downward forces. Then you have to read all these aspects and then prepare for examination. Good luck. And then you can still try to plot a graph of here plot A against B inverse. From your table, you can plot a graph of A against B. You can still plot a graph of B against A inverse. You can still plot a graph of A inverse against B inverse and obtain different relationship. So thank you, and stay tuned as we roll out alternative B, practical chemistry and practical physics. So keep watching youtube.com/@BestScienceBrain. Thank you very much.